Hi, this is Akash, and today I'm here to explain you the last part of the course that deals with transmission and distribution. Let's have a pre-test before starting the course. This test will score your basic knowledge on power system basics before you take the online course. Read the question, select the correct option or options and submit it. On successful completion, you will be provided with the pre-test score and directed to the e-learning page. Hello everyone, welcome back to the e-learning course on fourth part of Power System Basics that deals with transmission and distribution of power. In the previous part of the course, we have learned about some of the transmission and distribution of power. In this part of the course, we are going to deal with some more information of transmission and distribution of the generated power. As we discussed earlier, transmission and distribution is divided into two parts. In this course, we are doing the second part of transmission and distribution. So, let's get started with the course. Inner portions have increased opposing EMF to the flow of current. Effective conductor area decreases. Effective resistance increases. The charge carries constituting that current, usually electrons, are driven by an electric field due to the source of electrical energy. An alternating current in a conductor produces an alternating magnetic field in and around the conductor. When the intensity of the current changes, the magnetic field also changes. The change in the magnetic field in turn creates an electric field which opposes the change in current intensity. This opposing electric field is called counter EMF. The back EMF is strongest at the center of the conductor and forces the conducting electron to the outside the conductor as shown. An AC may also be induced in a conductor due to alternating magnetic field according to the law of induction. An electromagnetic wave impinging on a conductor will therefore generally produce such a current. This explains the reflection of electromagnetic waves from metals. Regardless of the driving force, the current density is found to be greatest at the conductor surface with the reduced magnitude deeper in the conductor. That decline in current density is known as skin effect, and skin depth is the measure at which the current density falls to 1 by E of its value near the surface. Over 98% of the current will flow within in a layer 4 times from the surface. This behavior is distinct from that of the direct current, which usually be distributed evenly over the cross-section of the wire. Cross-sectional area of a round conductor available for conducting DC current. Cross-sectional area of a round conductor available for conducting low-frequency AC. Cross-sectional area of a round conductor available for conducting high-frequency AC. The second effect that we are going to know about is proximity effect. Magnetic field of the adjacent current carrying conductor has an impact on the current distribution of the nearby conductor. For current flow in the same direction, concentration of current is decreased at the adjacent areas of the conductors. For current flow in the opposite direction, concentration of currents is increased at the adjacent areas of the conductors. Another type of effect observed in transmission system is corona. The second effect that we are going to know about. Another type of effect observed in transmission system is corona effect. When an alternating current is made to flow across two conductors of the transmission line whose spacing is large compared to their diameters, then air surrounding the conductors, composed of ions, is subjected to dielectric stress. At low values of supply and voltage, nothing occurs as the stress is too less to ionize the air outside. But when the potential difference is made to increase beyond some threshold value of around 30 kV, known as the critical disruptive voltage, then the field strength increases and then the air surrounding it experiences stress high enough to be dissociated into ions, making the atmosphere conducting. The ionized surrounding results in electric discharge around the conductors due to the flow of these ions, giving rise to a faint luminescent glow, along with the hissing sound accompanied by the libration of ozone. This phenomenon of electrical discharge occurring in transmission line for high values of voltage is known as the corona effect in power system. If the voltage across the lines still gets increased, the glow becomes more and more intense along with hissing noise, inducing high power loss into the system. There are other types of transmission line equipments also. They are dampers, spacers and jumpers. Click on each tab to know more. Vibration dampers are used to absorb aeolian vibrations of conductor of transmission lines as well as ground wire, OPGW and ADSS. Spacers are used to physically separate two conductors from each other to avoid short-circuiting of conductors. The power conductor is connected to insulator on one side of the tower and on the other side another power conductor is connected. But there is no electrical connection between these two conductors. This electrical connection is served by a conducting wire which is termed as jumper. These are the images of jumpers. Now let us discuss about insulators. Electrical insulator must be used in electrical system to prevent unwanted flow of current to the earth from its supporting points. In transmission and distribution system, the overhead conductors are generally supported by supporting towers or poles. The towers and poles both are properly grounded, so there must be insulator between tower or pole body. Current carrying conductors should also be insulated to prevent the flow of current from conductor to earth through the grounded supporting towers or poles. These are the images of various insulators like porcelain, glass, and polymer. There are mainly following types of insulator. They are pin insulator, which works at voltages up to 33 kilovolts, suspension insulator, which works at voltages above 33 kilovolts, strain insulator, used at the dead end of the high voltage line, shackle type insulator. For less than 11 kilovolts, shackle insulators are used as strain insulators. Egg or stay insulator, used to prevent stay wires from becoming energized from accidentally broken live wires. Let's learn about lightning arrestor. A lightning arrestor is a protective device which gives protection against any overvoltage due to the lightning surges. Lightning arrestor is kept in substation at a suitable place. It is connected between the ground and the line conductor. There are many types of lightning arrestors. Road gap arrestor, sphere gap arrestor, horn gap arrestor, multi-gap arrestor, electrolyte type arrestor, metal oxide lightning arrestor. Let's learn about lightning arrestor. A lightning arrestor is a protective device which gives protection against any overvoltage due to the lightning surges. Lightning arrestor is kept in substation at a suitable place. It is connected between the ground and the line conductor. There are many types of lightning arrestors. Road gap arrestor, sphere gap arrestor, horn gap arrestor, multi-gap arrestor, electrolyte type arrestor, metal oxide lightning arrestor. Click on each tab to know more. Firstly, potential transformer. The potential transformer may be defined as an instrument transformer used for the transformation of voltage from a higher value to the lower value. This transformer steps down the voltage to a safe limit value which can be easily measured by the ordinary low voltage instrument like a voltmeter, wattmeter, and watt-hour meters, etc. Here is the image of potential transformer with labels. Oil filling plug, HT terminal, pressure release device, nitrogen valve, oil expansion chamber, porcelain brushing, oil, HT coil, oil tank, cold lamination stack, LT coil, earthing terminal box, oil drain plug, earthing terminals, secondary terminal box. Click on each tab to know more. Current transformer. A current transformer is a device that is used for the transformation of current from a higher value into a proportionate current to a lower value. It transforms the high voltage current into the low voltage current, due to which the heavy current flows through the transmission lines is safely monitored by the emitter. Here is the image of current transformer with labels. Oil filling plug, primary winding, coil seat, porcelain brushing, secondary terminal, base, secondary terminal box, earthing terminal, lifting box, brushing clamp, tank with cover, primary terminal, oil level indicator, nitrogen valve, pressure release device. Our next topic is about switchgear. In an electric power system, switchgear is the combination of electrical disconnect switches, fuses, or circuit breakers used to control, protect, and isolate electrical equipment. Switchgear is used both to de-energize equipment to allow work to be done and to clear faults downstream. This type of equipment is directly linked to the reliability of the electricity supply. The switches, fuses, circuit breaker, isolator, relays, current and potential transformer, indicating instrument, lightning arresters, and control panels are examples of the switchgear devices. Click the respective images to know about LV, MV, HV switchgears. LV switchgear. Below 3 kV, switchgear system is categorized as low voltage switchgear or LV switchgear. Simplicity, efficient performance, high normal current rating up to 600 ammeter, high fault withstanding capacity up to 63 kA. Although air circuits breakers have long tripping time, big size, high cost, but still they are most suitable for low voltage switchgear for the above mentioned features. MV switchgear. From 3 kV to 36 kV switchgear system is categorized as medium voltage switchgear or MV switchgear. These switchgears are of many types. They may be metal enclosed indoor type switchgear, metal enclosed outdoor type switchgear, outdoor type switchgear without metal enclosure, etc. The interruption medium of this switchgear may be insulating oil, SF6 gas or vacuum. Medium voltage switchgear should be capable of normal on or off switching operation, short circuit current interruption, switching off capacitive currents, switching off inductive currents, some special application. All the above mentioned functions must be carried out with a high degree of safety and reliability. HV switchgear. The power system deals with voltage above 36 kV is referred as high voltage switchgear. High voltage switchgears are categorized as gas insulated indoor type GIS, air insulated outdoor type. Again, outdoor type air insulated circuit breakers are classified as dead tank type circuit breaker, live tank type circuit breaker. The essential features to be provided in high voltage circuit breaker to ensure safe and reliable operation. The breakers used in high voltage switchgear must be capable of being operated safely. For terminal faults, short line faults, transformer or reactors magnetizing current, energizing long transmission line, charging capacitor bank, switching off out of phase sequence. Let us discuss about circuit breaker. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. Unlike a fuse, which operates once and then must be replaced, a circuit breaker can be reset to resume normal operation. Isolator is another important part that we need to discuss about. Isolator is a manually operated mechanical switch that isolates the faulty section or the section of a conductor or a part of a circuit of substation meant for repair from a healthy section in order to avoid occurrence of more severe faults. Hence, it is also called as a disconnector or disconnecting switch. There are different types of isolators used for different applications such as single break isolator, double break isolator, bus isolator, line isolator, etc. Let's discuss the operation of vacuum circuit breaker. When two face-to-face contact areas are just being separated to each other, they do not be separated instantly. The contact area on the contact face is being reduced and ultimately comes to a point, and then they are finally detached. Although this happens in a fraction of microsecond, it is a fact. At this instant of detaching of contacts in a vacuum, the current through the contacts concentrated on that last contact point on the contact surface and makes a hot spot. As it is a vacuum, the metal on the contact surface is easily vaporized due to that hot spot and create a conducting media for arc path. Then the arc will be initiated and continued until the next current 0. At current 0, this vacuum arc is extinguished and the conducting metal vapor is recondensed on the contact surface. At this point, the contacts are already separated, hence there is no question of re-vaporization of the contact surface. For the next cycle of current, that means the arc cannot be re-established again. In this way, vacuum circuit breaker prevents the re-establishment of arc by producing high dielectric strength in the contact gap after current 0. These are few advantages of vacuum circuit breaker. A vacuum circuit breaker is such kind of circuit breaker where the arc quenching takes place in vacuum. The technology is suitable for mainly medium voltage application. Advantages of vacuum circuit breaker or VCB. Service life of vacuum circuit breaker is much longer than other types of circuit breakers. There is no chance of fire hazard like in case of oil circuit breaker. It is more environment friendly than SF6 circuit breaker. Beside that, contraction of VCB is user friendly. Replacement of vacuum interrupter is much convenient. Now let's discuss about gas insulated switchgear. In this type of switchgear, all the necessary components of switchgear can be assembled in very limited space. GIS is a kind of metal enclosed switchgear. That means all the equipments of the electrical switchgear are enclosed by gas-tight metal enclosure, and SF6 gas is used as insulation between live parts of the equipments and earthed metal enclosure. Gas-insulated switchgear is available from 12 kV systems to 800 kV systems. For establishing electrical substation in very limited place, this type of SF6 insulated electrical switchgear plays the major role. Gas-insulated components of substation are generally electrical bus bars, electrical isolators or disconnectors, circuit breakers, current transformers, voltage transformers, earth switches, surge arresters or lightning arresters. The main function of an electrical power distribution system is to provide power to individual consumer premises. Distribution of electrical power to different consumers is done with much low voltage level. Distribution of electrical power is done by distribution networks. Distribution networks consist of following main parts: distribution substation, primary distribution feeder, distribution transformer, distributors, service mains. The transmitted electrical power is stepped down in substations for primary distribution purpose. Now these step-down electrical power is fed to the distributor transformer through primary distribution feeders. Overhead primary distribution feeders are supported by mainly supporting iron pole, preferably rail pole. The conductors are strand aluminium conductors and they are mounted on the arms of the pole by means of pin insulators. Sometimes in congested places, underground cables may also be used for primary distribution purposes. This is about radial electrical power distribution system. In the early days of electrical power distribution system, different feeders radially came out from the substation and connected to the primary of distribution transformer. But radial electrical power distribution system has one major drawback, that in case of any feeder failure, the associated consumers would not get any power as there was no alternative path to feed the transformer. In case of transformer failure also, the power supply is interrupted. In other words, the consumer in the radial electrical distribution system would be in darkness until the feeder or transformer was rectified. This is about ring main electrical power distribution system. The drawback of radial electrical power distribution system can be overcome by introducing a ring main electrical power distribution system. Here, one ring network of distributors is fed by more than one feeder. In this case, if one feeder is under fault or maintenance, the ring distributor is still energized by other feeders connected to it. In this way, the supply to the consumers is not affected even when any feeder becomes out of service. In addition to that, the ring main system is also provided with different section isolates at different suitable points. If any fault occurs on any section of the ring, that section can easily be isolated by opening the associated section isolators on both sides of the faulty zone transformer directly. In this way, supply to the consumers can easily be maintained even when one section of the ring is under the shutdown. The number of feeders connected to the ring main electrical power distribution system depends upon the following factors. Maximum demand of the system. If it is more, then more numbers of feeder feed the ring. Total length of the ring main distributors. If length is more, to compensate the voltage drop in the line, more feeders need to be connected to the ring system. Required voltage regulation. The number of feeders connected to the ring also depends upon the permissible allowable voltage drop of the line. This is the ring main electrical power distribution system. Now let's discuss the process of distribution. Power goes from the 33 by 6 by 11 kV transformer to the distribution bus. There is usually another transformer near your house, namely distribution transformer, stepping down the voltage even further from 6 or 11 kilovolts to 440 volts. Only one of the three original phases along with neutral enters each house, domestic consumer. Let's learn about distribution transformer. Distribution transformers are generally small in size and filled with insulating oil. These transformers are available in the market in various sizes and efficiencies. Selection of distribution transformer depends upon the purpose and budget of the end users. The step-down transformers used for electrical power distribution purpose are referred as distribution transformer. There are several types of transformer used in the distribution system, such as single-phase transformer, three-phase transformer, pole-mounted transformer, pad-mounted transformer, underground transformer. Secondary terminals of distribution transformer deliver electrical power at a utilization voltage level to the consumer end via energy metering system. In case of three-phase distribution system, three-phase 4-wire secondary systems are adopted. Here, three phases, which means red, yellow, and blue phase conductors, come out from three low-voltage bushing studs of the transformer. The neutral wire is connected to the fourth bushing, which is also referred as a neutral bushing of the transformer. The neutral point of the distribution transformer is projected from the tie point of three-phase winding inside the transformer. In case of industrial heavy three-phase load, 4-wire system is directly delivered to the consumer end. In case of single-phase light load, one phase and neutral connection of the three-phase distribution transformer are connected to the consumer's energy meter. Secondary terminals of distribution transformer deliver electrical power at a utilization voltage level to the consumer end via energy metering system. In case of three-phase distribution system, three-phase 4-wire secondary systems are adopted. Here, three phases, which means red, yellow, and blue phase conductors, come out from three low-voltage bushing studs of the transformer. The neutral wire is connected to the fourth bushing, which is also referred as a neutral bushing of the transformer. The neutral point of the distribution transformer is projected from the tie point of three-phase winding inside the transformer. In case of industrial heavy three-phase load, 4-wire system is directly delivered to the consumer end. In case of single-phase light load, one phase and neutral connection of the three-phase distribution transformer are connected to the consumer's energy meter. The efficiency of distribution transformer is defined as the ratio between output power to input power of the transformer at full load condition. But in case of a distribution transformer, the concept is a little bit different, as the possibility of running a distribution transformer at its full load condition is nearly nil. The efficiency of the transformer is maximum at 50% of full load. Now that you have completed the course, you have learned to explain effects observed in transmission system, identify other transmission line equipments, define an insulator, list types of measuring or protection transformers, explain about switchgear, list essential features of high voltage circuit breaker, explain operation of vacuum circuit breaker, explain about gas insulated switchgear, explain about electrical power distribution system, list types of distribution, explain about distribution transformer. Thank you for your time. Hope you enjoyed learning. Click next to take the post test.